Let's discuss Unit 8 Theory of Computation and Compilers questions. Consider the following DFA that generates set of strings over the input alphabets A, B, C. Now identify that which of the following is the best description of the language for the above DFA. There are two approaches to this question. First approach is you have to trace the particular DFA and then find what is the string. The other approach is to test whether any of the four options are working for this DFA. The time saving process will be the second one. So first let's start with the first option. The language description will be L is equal to A star plus B star plus C star. This star denotes its clean closure, which means it can either have the occurrence of that particular alphabet or not. It means the occurrence of the alphabet can be 0 also. What is this plus symbol outside the bracket? This will state that at least one of the string is going to be present, which says that empty strings cannot be processed in this particular language. It does not support empty string. Let's take ABC. From the DFA we can understand that Q0 is the initial state based on the symbol arrow mark, and Q0 will be the final state too based on the double circle that it has. How shall we find that ABC is being accepted by this particular DFA or not? We have to start from Q0, go through ABC and check whether it is ending at Q0 again. So let's trace it. From Q0 we have A transition to Q1. So this is A. From Q1 for B we have Q2. So this is B, and from Q2 we have to go to Q3 for the input C. Is this string ending up in final state? No. ABC is not the only string that is being generated by option 1. It is just one of the strings. When one of the string is being rejected by the DFA, it means this language is not the language of the above DFA. We can rule out option 1. Now let's take option 2. Language is equal to A plus B plus C, clean closure. Then we have A, B, C with the plus symbol here, and then A plus B plus C, clean closure. This can have 0 occurrence, this can have 0 occurrence, but this must have at least one occurrence, which states that the minimum string that can be generated will be ABC. We have already found that ABC will be rejected by this particular DFA. So now we can rule out even option 2. This is the reason I took ABC for option 1 also. So let me give the transition for this ABC. From Q0 you are going to Q1, from Q1 you are going to Q2, and from Q2 you are going to Q3. For A, B and C input, Q3 is not a final state. So this string is rejected by the DFA given above. Now let's go to the third option. Language description is set of strings all starting with ABC but ending with C. Q0 to Q0 has C transition and Q5 to Q0 has C transition here. If a string has to end by C, the previous state should be Q0 or Q5. Then again when you have Q1 here, Q1 is also having Q0 transition with input C. So the C possibilities are only 3. The minimum string is ABC then C, because ABC we know it is not going to be accepted, but here they are saying it is starting with ABC and ending with just C. So far we have traveled till Q3 for ABC. From Q3 what is C transition? We are again standing in Q3. Q3 to Q3 is a self loop for C. This is also not a final state, which states that this string will also be rejected by the automata. We can take another string here, ABC, then we will have ABC, then a C again here. So ABC we have come here, we have A, we have B, we have C, then C. This string is getting accepted, but this string should also get accepted. When we say this is the language of DFA, all the strings should be accepted. When one string is accepted and one string is not accepted, that is not the language of the DFA. So taking A, B, C, C or only A, B, C into consideration, we can tell that third one is also not the right answer. Now let's check for last one. Set of strings all having even count of substring ABC. It means you can have ABC, ABC, then ABC, 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 ABC. These are all even counts. This is 2, this is count 4. What about including 0? When the count is 0, we can say empty string is also accepted. Since the initial state is given as the final state, this declares that empty string is also accepted by this particular DFA. If the start state of a DFA is also a final accepting state, then the DFA accepts the empty string, which states that including 0 is fine for now. Now let's check for double ABC count here. A, B, C, then again we will go for A, we will go for B, then we will go for C. So this is even count, this is getting fine. Now we will check for 4 times of ABC. So once we reach Q0 for 2 times of ABC, again we can go ABC and come back to Q0 again. So even count is accepted here along with 0 count is what they say. So this is the best description of the language for above DFA. Set of strings all having even count including 0 of substring A, B, C. Let's take B, ABC, ABC, B. So it starts with B, Q0 with input B will stay in Q0. You traverse for 2 times of ABC. From Q0 again if you have input B, it is staying in Q0 which is final. So substring ABC means you can have anything in the front and in the back. Whatever is occurring here, this particular ABC pattern should be in even count. So option number 4 will be the right answer for this particular question. Next question, consider the following DFA. Which of the following NFA is valid for the given DFA? The initial state will be Q0. What about the final states? We have 4 final states, Q2, Q3, Q4, Q5. One way to work with this problem is to set a set of strings from the given DFA. Check whether all the strings are getting processed by the NFA in the options. This is a very time consuming process. There is another way. We have to pick one such string that works for DFA but not for NFA that is given in the option, or pick one string that is accepted by the NFA and not accepted by the DFA. It means if this automata accepts a string, it should be accepted by the NFA given below. If an NFA given in the option accepts a particular string, that string should not be rejected by this DFA. Both should accept the string is what I am trying to say. But you can either prove it in this way or this way. Both are right. We will work it out in both the ways for this particular problem. So first take the strings in DFA. Let's take the string AAB. In DFA, from Q0 to Q1 we have A. From Q1 to Q2 we have another A. From Q2 to Q3 we have B. Q3 is an accepting state, so this is a valid string in DFA. Now what we will do is, we will check whether we are able to get it in 1, 2, 3 and 4. We will start with Q0. We have A. This A can be taken under self loop, another A and then B. It is ending up in final state. So it is accepting. What about option 2? We have A, B. This is also fine. Coming to option 3, here only one state is final state. The remaining states are not final state. So let's check A, B. It is not ending in a final state, which says that this particular NFA can be removed from the answer list. So we will remove this. Let's check for option 4. A, B is there. This is one way to process. We are taking DFA accepting string and checking with the NFA is given in the 4 option. Now we will work it the other way. We will take a string, and that string, if it is accepted by DFA, then that is the valid NFA. If that is not accepted by the DFA, we can just rule out the option. We will go for A, B, C, AC. Let's check whether it is first available. We have A, B, C, A, C. It is ending in a final state. Regarding option 2, we have A, B, C in loop here, then A, then C. This is also getting accepted in second NFA. Now check whether this string A, B, C, AC is accepting in DFA. We have A, then we have B, then we have C. We are still in Q3 state. So from Q0 to Q1 we have A, from Q1 to Q3 we have B, from Q3 we have self loop which is C. After C we are processing A. It is moving to Q5. From Q5 we have to search for C transition, but in Q5 we don't have C transition. If there is no C transition, it means this string is not accepted in the DFA. Using this string, we are actually neglecting the options 1 and 2. 1 and 2 are accepting a string that is not accepted by the DFA. Now let's check for option 4. Here we have A, here we have B, here we have C. ABC is there. From Q2 we are having A transition. We are in Q3. From Q3 you don't have any C transition. From Q0 to Q1 we have A, Q1 to Q2 we have B, Q2 to Q2 we have C. For A, one way we went to Q3. From Q3 there is no transition. So this automata is not accepting. We will go the other way. A, B, C. From Q2 we are moving to Q0. From Q0 do we have any C transition? No. Option 4 is not accepting the string that is not being accepted by DFA. So DFA and option 4 are rejecting the same string, but that string is being accepted by 1 and 2. By taking this into consideration, we will even remove 1 and 2 from the answer list. So which automata is valid for the given DFA? Option number 4. We got a string from the DFA and then checked in NFA. One of the NFA failed. Now we got a string and checked in 2 of the NFAs. It worked, but it got rejected by the DFA. The same string got rejected by another NFA also. For all these 3 strings, the DFA and option 4 automata are working in the same way. They are accepting the same strings and they are rejecting the same strings. In that case, we conclude that the NFA in option 4 is valid for the given DFA. So the only challenge regarding this question in exam point of view is to find the right string. I hope you get the essence of focus during examination. Apart from the usual tension that you have in exam, if you have other stuff running in your mind, these questions will take a lot of time and eventually end up with the wrong answer. And there are complaints that sometimes the DFA is not clear. You have to scroll and then find it out. If that is the difficulty, that is not in our hands. If you don't have focus, you will not find this string or this string so easily. Since I had the answer key in my hand, I know DFA and option 4 will work the same way. But in examination, you don't know which of the option will work the same way. So you have to test every string in every option to check whether they are equal or not. Next question. Arrange the following parsers in increasing order of their power of handling grammars. That is from the least powerful parser to the most powerful parser. Out of these 5 options, one parser is top-down parsers while the others are bottom-up parsers. We will start with the least powerful one, LL of 0. 0 means there is no look ahead. It cannot handle left recursion or ambiguity, and this is top-down parser. So the least powerful will be LL of 0. Two of the options are starting with LL of 0, so we will rule out the other two. After LL of 0, we have LR of 0. Again, there is no look ahead. Many grammars cause shift reduce conflicts. So compared to LL, LR is better, but again LR has some problems. So the next order will be LR of 0. This is there in both the option. After LR of 0, we have SLR. This uses follow sets to reduce ambiguity and it is stronger than LR of 0. So the next order will be SLR and it is available in both the option. After SLR, we have LALR. Nearly as powerful as LR of 1. So both are almost equal in power, but it is working with smaller tables. In this case, we are considering LALR to be less powerful than LR with look ahead bun. So here LALR will be coming first. So we will rule out option 1 also. After LALR of 1, we have LR of 1 full look ahead. This handles widest class of grammars. So they are asking the power of handling grammars from least to most. So this is the most powerful parser and we are ending up with LR of 1. Option number 3 will be the right answer. The question might be in increasing order or decreasing order. Read the question properly and then answer. Next question, which of the following grammars are only context free? A context free grammar is a formal grammar where every production is of the form A produces alpha, where A is a single non-terminal like capital S, capital A, capital B, and alpha is a string of terminals and or non-terminals including epsilon. So let's start with A grammar. This actually violates CFG rules. This has a terminal on the left hand side. That's why we are ruling out A grammar from the answer list. So we can remove option 1 and 4 which has A in the answer. What about B grammar? We have S derives capital A B. This is fine. And A derives capital SA. This particular rule introduces indirect left recursion through S derives non-terminal A and terminal B. This will create a cyclic dependency between non-terminals S and A which will lead to ambiguity in derivations. This grammar is actually allowing context-sensitive behavior. The derivation of A depends on the context of S, which violates the independence required in context-free grammars. So we are even ruling out B. What about C? S derives AS, S derives AA, A derives A. At any stage, check whether it will be ending with a terminal. Yes, it will end. So C is a context-free grammar. What about D? S derives capital A and terminal B. S derives terminal A and non-terminal A derives A. This is also fine. What about E? S derives SB and A derives A derives epsilon. Actually, A is not reachable from the start symbol. This is one problem. Another problem is the only production that is available here is S derives SB. Again and again it will be deriving in this way. This S will not eventually lead to a terminal. So we say this grammar is not context free. S non-terminal does not end with a terminal. It means they are not talking about this B terminal. Ultimately, this non-terminal should end up with a terminal. Say for example, here we have capital A and S. This S is somewhere ending with this particular terminal and this non-terminal is ending with a terminal finally. We have the possibility of getting terminals from S in both C and D. But here, how much ever derivations we go, it will still have capital S and B only. This capital S will never end with a terminal because there is no non-terminal that is being given in other production. This is one problem. The second problem is A production is not reachable from S. S never uses capital A in any of its productions. Since A is not reachable, it is effectively useless in the grammar. You are going to work only with S and B and there is no mention of capital A. What is the use of giving these two productions when it is not given in the start symbol? So keeping these 2 points in mind, we are saying E is also not there in the answer list, which is making us rule out option 3. Option number 2. C, D only will be the right answer. Only these two grammars are context free grammars. Next question. Match list 1 with list 2. I think this is a repeated question from previous year question paper. Let's first understand the symbols. Capital V is a set of non-terminal symbols. This summation notation is a set of terminal symbols. Lambda and beta that are used here, they are strings of terminals and or non-terminals. Now let's start with type 3 regular grammar. This is of the form A derives terminal non-terminal or A derives terminal, where capital A and B belong to non-terminal and small a belong to terminal. Non-terminal derives a non-terminal and a terminal or a terminal, which is equating it to this particular format. So A will be mapping to 4. A4 is available only in one option. If you are sure about regular grammar, you can complete this question. Next we will go to type 2 grammar, which is context free. A derives beta. Now just map this. Non-terminal derives a combination of terminal and non-terminal. Otherwise epsilon is what they say by the star symbol. This is actually available in option 1. So B will be mapping to 1 in list 2. This is B1. Then we have type 1 grammar, which is context sensitive. Alpha derives beta. Alpha belongs to union of non-terminal and terminal. Beta belongs to union of terminal and non-terminal. Here it is actually plus symbol and here it is star symbol. And alpha is less than or equal to beta is given here. For the context sensitive behavior, they have even given this particular condition. Now just find a similar expression here. Lambda union beta derives lambda with terminal and non-terminal union with this particular closure symbol and then beta, where lambda belongs to union of terminal and non-terminal and beta belongs to union of terminal and non-terminal. This particular part is actually expanded in this way. So we can map type 1 grammar C to 2 here. C2 is available here. What about type 0 grammar? It is unrestricted grammar. Alpha derives beta, where both are strings of terminals and non-terminals. Just take V union summation star derives V union summation the whole star. This is what is given exactly in option 3 of list 2. So D will be mapping to 3. Option number 3, A4, B1, C2, D3 will be the right answer. Next question. From here we are entering into the comprehension part. 5 questions are based on the given 3 address code sample. Consider the following 3 address code sample for solving the questions. Let's see the code first. T1 is equal to y plus 2, initial is equal to x divided by T1, limit is equal to 10. If I greater than j, go to 105. So if I is greater than j, we have to go to 105. If number is greater than b, go to 107. If this condition is true, we have to go to 107. From this we can understand, if I is greater than j, it has to check another condition, num is greater than b. What about this go to statement? It is the else part of this particular if. And what is this go to statement? The else part of this particular if. From 107 till go to 103. What is 103? It is getting back to the if condition again. This part is actually a loop. It means we are checking for two conditions. If so, we are executing from 107 to 110. After finishing 110, we are again going and checking the condition. When you are going for a repeat of executing the same set of statements, it is actually loop. Once the condition fails here, or if the condition fails here, you are getting out of the loop where you are having two statements, j is equal to I minus num and k is equal to j plus b. So understand, the loop continues only if I is greater than j. Inside the loop there is also a nested condition, num is greater than b. If that is also true, we are updating the values of num, b and I and then going for checking the condition again. If num is less than or equal to b, the inner nested loop will be getting out. After the loop, we are computing two values is what they are trying to tell us through this 3 address code sample. So in intermediate code generation of compiler design, you are having this particular comprehension. Now let's get on to the first question. Which of the following is the correct high level code for the given TAC in the passage? We have to check the 4 options and then see whether the logic is actually retained. Now let's go through option 1. The values are initialized. They have given I greater than j or num greater than b. It executes even if I is less than or equal to j, but when num is greater than b, it means when one of the condition is true, it is going to execute these 3 statements. But the logic is both the conditions should be true, only then you can enter the body of the loop. So here it is violating. This breaks the original loop logic, which requires I greater than j first, then num greater than b inside. So this is breaking the original loop logic. 1 is out of the race. Get into 2. While I greater than j or num greater than b. Here also this is the problem. The loop continues if either condition is true, but in our TAC sample we have to have both the conditions to be true. So this is the mistake in 2 also. What about 3? If I greater than j while num greater than b, num is equal to limit minus 1 and they have given these 2 statements in else part. Actually, this block is wrong. If I is greater than j, they could have given like while num greater than b, you have to put all these 3 statements inside the body of the loop and then get it out. This is not the else part. This is a part of the loop. So this logic is also not retained here. This reverses the logic. Updates I only if I is less than or equal to j. It means it is on the else part they are saying. The loop on num greater than b is inside I greater than j condition, but it does not update I, so the loop condition never changes. This if part here, it is changing the value of I. In the 3 address code sample they have given. But here this is working only with num. If you have to update the value of I, it is available only in the else part. What does this mean? This loop condition will never change because we are not going to update I since it is present in the else part. So this is the reason we are ruling out even option 3. From this we know option 4 is right, but we will see how it is right. Here they have placed I greater than j, one condition is fine, and num greater than b along with and, it means both the conditions have to be true. Check for the body of the loop. Num is equal to limit minus 1, b is equal to y plus 2, I is equal to I minus num. All these 3 are fine and these 2 statements are also fine. What about init value? Instead of saying x by t1, they have substituted the value of t1 here. It is nothing wrong. This is equivalent to x divided by t1 where t1 is equal to y plus 2. So from this we understand that it matches the TAC logic. Loop continues only when both these conditions are true. Inside the loop it updates all the 3 variables. After the loop we are computing j and k. So all the logic is preserved here. So we are going with option number 4 as the right answer. This is the correct high level code for the given TAC as per these 4 options. Next question. What are the various leading statements for the TAC given in the passage? Leaders are the starting points of basic blocks. We will get into basic blocks in the next question. As of now, we will just find the leaders. A statement is a leader if it is the first statement of the program, it is the target of a jump, it immediately follows a jump instruction. Now we will see step by step. Let's get into rule 1. So this is 1, 2 and 3. The first statement. This is the very first statement of the TAC code. So 100 is always a reader. So 100 is present in all the 4 options. What about rule 2? Targets of jumps. 103 is the target of go to 103. We have go to 105, go to 107 and go to 111. 103, 105, 107, 111. All these are targets of jumps. The targets of jumps are leader. This is rule 2. So 103, 105, 107, 111 is missing. So 1 is ruled out. We have 103, 105, 107, 111. It's fine. We have 103, 105, 107, 111. We have 103, 105, 107, 111. It's fine. So only one option is ruled out as of now. Now the third rule. Statements immediately after jumps. There are 2 if conditions. One in 103 and one in 105. So they are saying jump instruction. We can consider if here. The first if is present in 103. It immediately follows a jump instruction means this part is a leader. It means it is actually the else part of this particular if block. So 104 is a leader here. Then check the other if condition which is at 105. Here we have an if condition and this is like the else part. So we are including 106 also. They have not included 104, 106 here. So we can rule out 2. 104 is missing here. So we will rule out. What about the fourth option? 104 is there. 106 is there. 100, 103, 104. 105, 106, 107 and 111. These are the leaders for the given TAC sample. So we will go with option number 4 as the right answer. Consider only go to here and consider if here. Line 103 is a conditional jump. If I greater than j is false, the program continues to line 104. Similarly, line 105 is a conditional jump. If num is greater than b is going to be false, the execution continues to line 106. That is what I told. It is like the else part. That's why we are including 104 and 106. What is the purpose of identifying leaders? To break code into basic blocks. That is what we are going to do next. Perform local optimization. Build control flow graphs. Enable data flow analysis. So we will get on to the next question. Which of the following is the correct flow graph for the TAC given in the passage? To determine the correct flow graph, there are 3 steps. Identify the basic blocks using the leaders. So we already have the leaders here. Understand the control flow between those blocks. Match the control flow to the adjacency matrix. That is the flow graph options. Now we have to find the basic blocks. Just mark the leaders. 100. 103, 104, 105, 106, 107 and then we have 111. 100 to 102. This is block 1. You have to now recollect the leader statement. Leaders are the starting points of basic blocks. Whenever you have a leader, that will be the starting point of the basic block. So this is one block. 103 is block 2, 104 is block 3, 105 is block 4, 106 is block 5. From 107 till 110 you don't have a leader. So this particular set of 4 statements will be block 6. Again we don't have a leader after 111. So this will be block 7. This is how we will be finding basic blocks from leaders. You just mark the leaders. Every leader will be the starting of a basic block. So if 103 is going to be a leader, the statement preceding it will belong to the previous block. Since we have 103, 4, 5, 6, 7 continuously to be leaders, we are just considering them as separate blocks. After 107 till 111 you don't have any leader. So the line before 111 will belong to the previous block. You have to find the leaders, you have to find the basic blocks. After these two are done, we are going to see the control flow between blocks. From B1 we are moving to B2. There is straight line flow. It means after completing block 1 we are moving to block 2. What about block 2? Block 2 we have if I greater than j. Don't see the line numbers, just see the blocks, otherwise you will get confused. This is block 2. If I greater than j is going to be true, where it will go? It will go to 105. What is 105? It is block 4. What happens if this particular condition is going to fail? If this is going to be false, it will go to 104, which is nothing but block 3. So it has two control flow here. B2 to B4 happens if I greater than j is true. B2 to B3 happens if this I greater than j becomes false. So these are all additional explanation that has been given for understanding. Now block 2 is done. After block 2, now we have to start with block 3. From block 3, we have a go to statement to 111. What is 111 actually? It is block 7. So from B3, we are moving to block 7. Don't go with the line numbers, just go with the block numbers. Next block will be block 4. Block 4 is 105. Again we have two options. If it is going to be true and if it's going to be false. If it is going to be true, we are going to 107. 107 is block 6. If it is false, we are moving to the next immediate block, that is block 5. So again there are two control flows. B4 to B6 happens when the condition is true. B4 to B5 happens when the condition is false. These are just explanations to say how this flow is happening. Now we will get into next block B5. From B5 where are we going? We are going to go to statement 111 code line. This is again B7. So B5 is going to B7. This is the next control flow. From B6 where are we going? This is B6 block. From B6 we have a go to statement called go to 103. So from B6 we are going to 103. 103 is which block? Block 2. So B6 is having the flow to B2. B6 means you have to take all together all the 4 statements. This is fine. This is having straight line execution. This is having straight line execution. From B6 actually you should move to B7. But here you have a jump. Go to 103. So from B6 the only option that you have is to move to block 2. What about the final block B7? From B7 there are no outgoing edges. It means this is with respect to the flow graph they are telling. But we are reaching the end of the code. So we are saying B7 to end. It is not going to any other block. So no other block is involved here. B1 is moving to B2. B2 is moving to two other blocks. B3 and B4. B3 is moving to B7. B4 is moving to B5 and B6 based on the conditions true or false status. B5 is moving to B7. B6 is moving to B2. B7 has no movement. It is just moving to the end. Now we will build the flow graph matrix. We have to number the blocks B1 to B7 row wise as well as column wise. So this is nothing but B1, B2, B3, B4, B5, B6, B7. This is the same thing here. So now let's take this particular control flow. I have presented in text form so that it will be clear for you. From B1 to B2 we have a edge, so we are marking 1. Now B2 is having 2 edges here, to B3 and B4. So from 2, for 3 and 4 we have 1 here. What about B3? It is moving to B7. So we are having 1 in 7th column here. What about B4? B4 is moving to B5 and B6. So we will have 1 in 5 and 6. B5 is moving to B7. So we are having 1. B6 is moving to B2. So we are having 1 under second block. B7 is going towards the end. So there is no entry. Except the ones, fill all the places with zeros. This flow graph is available in option number 1. Option 1 will be the right answer. Now we will see what is wrong with the other 3 options. There are actually 7 blocks, but 2 and 4 are having only 6 blocks. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Seeing the number of blocks itself, we can cancel 2 and 4. What about 3? Instead of 3 and 4, they have given us 4 and 6 here, which is wrong. So the entries are totally wrong. B7 has no 1 entry, but here they have given. So we are ruling out 2, 3 and 4 and sticking to option 1. Understand the steps clearly. Find the leaders and then the basic blocks. This is the first step. After that you have to find the control flow. This is the second step. From there you have to get this particular flow. After that place it in the matrix. That is the third step. So basic blocks using leaders, control flow between blocks and matching it to the adjacency matrix. These are the 3 steps. If you find it difficult when you follow it initially, please go through once or twice to get clear understanding. Next question. What all blocks does block 3 and block 5 dominate in the flow graph for the TAC given in the passage? This question and the previous question lies in the block number. Some people will number the block from 0 to 6. If you are going to do it in that way, the previous question will not be problematic, but this question will be problematic. Some people have numbered the blocks from 0 to 6, and because of that they were not able to get proper answer for this question. So unless it is specified, you always go with the numbering 1 to 7. Regarding the previous question, if this is going to be from 0 to 6 and 0 to 6, still the flow graph will not have any change, because you are going to change these flows accordingly. That will not be a problem. But this question might turn out to be a problem. This is the block and the related statements, and this is the control flow graph or the summary that we have from the previous question. Now we have to find domination. What is this dominates? In a flow graph, block A dominates block B if every path from the entry block to block B must go through block A. Say for example, this is the entry point and this is going to be block B. From here to here, you must always travel through this part. This means that A dominates B. If there are other ways, say for example, you can go with C or you can go with D, then A does not dominate B because it has alternate routes. A block always dominates itself. So from this you can understand block 3 will definitely dominate 3, block 5 will definitely dominate the same block. It will dominate itself. If there is any way to reach another block without passing through it, then it does not dominate that block. As I told you, if it has C or D to B, Even without A, if you are able to reach B, then A does not dominate B. Now we will find domination for all the blocks. Let's take block 1. This is going to be the entry block. Only when you start with this particular block, you will be able to enter other blocks. Only from B1, you will be able to move to other blocks. So it is dominating itself and the other blocks. What about B2? If B2 is going to be true, it will move to block 4. If block 4 is true, it can reach block 6. If it is false, it can reach block 5. If block 2's condition is going to be false, it will directly go to block 7. So you can reach all the paths from block 2. So this is dominating itself and the other blocks also. This is block 2's domination. What about block 3? From block 3, what is the only possibility you have? You are going only to block 7. Is there any other way that you can reach block 7? You can reach it from block 5 also. So the only block that B3 is going to dominate will be B3. B4, B5, B6, B7 can be reached without going through B3. So B3 dominates B3. So block 3 is dominating only 3 is given only in one option. So we have clearly told it will not dominate 4, 5, 6, 7. So 4, 5, 6, 7 entries will be wrong. From this itself we can rule out the other 3 options. Let's take block 4. From block 4, you can move to block 6. This is possible. If it is false, you can move to block 5. So both the possibilities are there and along with dominating itself, which is B4. So B4, B5, B6 is possible from B4. So B4 dominates 3 blocks. B5 and B6 are only reachable from B4. Because from B4 only there are 2 branches to B5 and B6. Similarly, B3 is reachable only from B2. What about block 5? Block 5 is actually 106, which is again a go-to statement. Again, it need not go through block 5, it may go through block 3. You have to consider the possibilities. Since you have told block 5 to be reason for not telling B3 dominates B7, you cannot rule out this. There is a possibility from here itself you can go to B7 without entering block 5. When there is a possibility, it dominates only itself, so only B5 is getting dominated here. This is also being asked in the question. So block 5 will dominate only block 5. So in order to go to block 6, B4 is enough. So 6 will not be there. For 7, there is another possibility from B3. These 3 options can also be ruled out with block 5's answer. So option number 1, block 3 dominates 3 and block 5 dominates 5 will be the right answer. Now let's check block 6 and block 7. Block 6 does not dominate anything except itself, because from block 6 we are going to block 2. Is there any other way to reach block 2? Yes, from B1 also you can reach block 2. This is not the only way. So B6 will dominate only B6 here. What about block 7? It is reachable from B3 or B5. But from here it is just end of the segment. So it is dominating only B7. I have given you the domination for all the 7 blocks with explanation. For 3 and 5 alone you can take it for this question. For the rest of the blocks you can use it for your learning purpose. Next question and the final question of the comprehension. Which of the following is the optimized version for the given TAC? Usually in optimized version we will be eliminating dead code. There are lots of steps. But before getting into the steps, let's first see what is wrong with the options now. Here there are only 110 line of code, 100 line and here 110. But the reference in the optimized version is still 111, which states that option 1, 2 and 4 are wrong. Without even working out anything, you can say 3 options are wrong. What about option 3? T1 initial limit is fine. What about num is equal to 9? Actually, it is coming inside the loop here. So, num is equal to limit minus 1, limit is 10 minus 1, num value is 9. But it has to be placed inside the loop, but here it is placed outside the loop. This is one problem. And here they have given if I greater than j, go to 105. 105 is having this particular line. 106 is the right path here. They have renumbered everything, but they have retained the same go-to jumps. So this option is also wrong. From this, what you can understand is, this question has been dropped in the official answer key. Now for learning purpose, we will just try to find the optimized version. Lines 107 to 110 is actually the loop's body content. You should not change it. The optimized version can be taken in this way. T1 is equal to y plus 2. Initial is equal to x by T1. Limit is equal to 10. Coming to this particular condition, here there is a repeat. If I is greater than j, else you are going. If num is greater than b, else you are going. Here you can find a logic. If num is less than b, we are changing it to a single statement. Instead of saying num greater than b, go to one position, else go to another position, we can change this as if num is less than or equal to b, go to the else position, otherwise keep executing. So they have used the alternative logic here and here also. We are applying this logic in the optimized version. They say if I is greater than j, you have to go for the next condition. Otherwise, you have to go for this particular statement. Now what I have done here is, if I is less than or equal to j, go to 109 where we have j is equal to I minus num. Else it will move to the next statement automatically. So if true, it will go to 109. If false, it will go to the next statement. If false means the condition I greater than j will be equal to true and it goes to check the next condition. Now see, if num is less than or equal to b, go to 109. So when this condition becomes true, it will again go to 109 line. But when this becomes false, we can understand num greater than b will become true and it will enter the body of the loop. So the body of the loop will be num is equal to limit minus 1. Instead of having b is equal to y plus 2, we can reuse this particular variable t1 as they have done in some of the options here. So instead of b is equal to y plus 2, we are using b is equal to t1, I is equal to I minus num, go to 103. This part will be the body of the loop and it has not changed from the original logic. Only when both the condition become true, both the original condition will become false and get out of the loop. So till then the loop will be executing. Now in 109 we have this particular line and in 110 we have k is equal to j plus b. These lines are not changed. Actually here you can see j plus t1. Here you can see I plus b. These are actually not wrong, but the body of the loop is not changed in the high level code. Just take the high level code. The three statements have not changed. The only change that I have done here is to the if condition here. So let me once again tell you, if number is greater than b, we are entering loop body. If number is less than or equal to b, we are getting to j is equal to I minus num. Similarly, when I is greater than j, we are entering to this particular part. Else, we are entering to j is equal to I minus num. Instead of having these many statements, we are just taking like when the condition becomes false here, when I is less than or equal to j, I am just asking it to go outside the loop. I am giving the failing condition here and then coming out of the loop directly. Till then, till I greater than j is going to be true, the body of the loop will be getting executed. Let's take I is equal to 10 and j is equal to 5 for example. So here I am going to check 10 greater than 5. If it is true, it will go to 105. It will check for the next condition. Take num to be 2 and b to be 1. 2 greater than 1. If it is true, it will go to 107. Just check the same logic here. 10 is less than or equal to 5. Is it true? No. If it is not true, it will not go to 109. It will go to the next statement. Now, 2 is less than or equal to 1? No. So, it will not go to 109. It will go to the next statement. In case if the condition fails, when I becomes 4 and j becomes 5 here, what happens? 4 is greater than 5 will be false. It will go to 111. It will come to this particular line. Now here 4 is less than or equal to 5 means it will directly get to 109, which is j is equal to I minus num. The logic is the same, but in optimized version I have just decreased the count of line by 1. That is the only difference done here. We have actually reduced 2 lines here. This is the optimized version for the given TAC. This is done based on the high level code that was given in the first question of the comprehension. But in general, when you want to find the optimized version, you have to find the basic block, build the control flow graph and identify the loop, branch and unreachable code. We have to perform local optimization. Local optimization should be done within each block. Optimize this part, this part, this part, this part separately. Within block, whatever you do will be local optimization. There you can do constant folding, common sub-expression elimination, copy propagation. This is for learning purpose. This is not for the question. Constant folding means limit is given a value of 10 and they have given num is equal to limit minus 1. So instead of having 2 line of codes here, num is equal to 10 minus 1 which is equal to 9. So we can change this as num is equal to 9 as they have given in one of the optimized version option. This is constant folding. What is common sub-expression elimination? So here instead of having y plus 2 and y plus 2, we are reusing it with t1. What about copy propagation? When they say b is equal to t1, k is equal to j plus b, instead of using this particular b, you can directly make it as j plus t1. This is copy propagation. Just to tell you what are the steps I am using the same code. This is not for the question. The next step is to apply global optimization. This has to be done across blocks. Local is within each block. In across blocks, what are the process? Dead code elimination, loop invariant code motion, strength reduction. What is dead code elimination? The variable initial is not at all used. So you can remove it. B is equal to y plus 2 is redundant. So instead of this, you can replace it either this way or the other way is to go for move computations outside loop. These two values are not going to be changed anyhow means this can be moved outside the loop. It can be calculated only once and it can be reused again and again. So strength reduction is replacing expensive operation with cheaper ones. It is not relevant to this particular code, but usually when there are lots of multiplications, you can make it with successive additions. The last step is simplify control flow. Makes the code easier to analyze and generate. We have to merge blocks with only jumps. Then flatten nested branches wherever possible. So these are the usual steps that we carry out. But regarding this question, this intermediate 3 address code is actually converted to high level code. So based on that only we can make some changes. So I have made changes only to the two conditions that is present here and a change to the B value inside the body of the loop. Other than that, nothing is done. I have given this optimized version based on the first comprehension question, high level code. This is not done in general. If you have to work it out in general, you have to go with constant folding, you have to go with dead code elimination. There are lots of process. But for this particular question, we cannot go so deep because this is just a sample. Initial might be used after 112. Limit might be used after 112 line. See, they have given num greater than b, I greater than j. Where did I come? Where did j come? Where did num come? Where did b come? We don't know. So this is just a sample code. With the sample code, we can do only this much is what I am trying to tell you. With this, we are completing Unit 8 questions.